Okay, in this video we will go through the 2015 Chemistry Foundation paper. This question is about metals. Which unreactive metal is found in the Earth as a metal in itself? Well, aluminium reacts with oxygen to form bauxite. Magnesium is a very reactive metal, so both reactive metals. Gold, found as nuggets, is the answer. Complete the sentence. Aluminium is an element because aluminium is made of only one type of. You could have atom or atoms. 1 mark. Question 1B. Question 1C. Figure 1 shows the electronic structure of an aluminium atom. Nucleus, and we have around the nucleus, hopefully you'll remember this, electrons in their different shells. So, use the correct word from the box to complete the sentence. The nucleus of an aluminium atom contains something and something. Well, we told you that the electrons move around. What's left over out of these? Okay, not ions. Okay, ions are atoms with charge. Protons, that sounds good, and neutrons. Remembering that protons are positive. These guys have no charge. Okay, so the answers are protons, neutrons. In the periodic table, aluminium is in group. So look to your periodic table here. Pull your periodic table up, I'll put it across here like this. The symbol for aluminium is Al. We're looking for Al, and if you look, there it is. Okay, so we look up here, 3, it's in group 3. So, the answer therefore is group 3. Okay, good. Over the page, questions going on about aluminium quite a bit here. Aluminium is used as a kitchen foil. Show a symbol for the box. Shows aluminium, ALU. Okay, symbol shows that aluminium can be recycled. It does not show the correct chemical symbol for aluminium. What is the correct symbol for aluminium? Back to your sheet. Okay, Al is the chemical symbol for aluminium. You have 2 reasons why aluminium should be recycled. 2 reasons aluminium should be recycled is, firstly, it is a limited resource. Okay, another reason is that it is expensive to mine and extract, and therefore cheaper to recycle. Okay, another thing that you could mention, so this is 1 point, this is 1 point in itself. A further one, okay, is that it reduces its effect on environment. We're talking about here pollution or landfill. Question 1A. Aluminium has a low density, conducts electricity, and is resistant to corrosion. Which one of these properties makes aluminium suitable for use as kitchen foil? Well, the most appropriate one here, if we're thinking about it as a food thing, is we don't want it to corrode. Okay? We want it to be resistant to corrosion. Why would it corrode? Well, it's the exposure to food and water exposure. Okay, food containing water. So you would have 1 mark for identifying the property there, and 1 mark to, let's change that to from, then it makes a full sentence. 1 mark there for giving me a reason, so the reason for your answer. Remember always to give a reason for your answer if it's a 2-mark question. Okay, that was the end of that question, and we got 10 out of 10. Question 2. Copper is a transition metal. Where is copper in the periodic table? Again, we need to get our periodic table out. okay, just to check where copper is. So pop that out again. And it's money, it's marks for old rope here, guys. You just got to find where it is. So copper is here, okay. So if you remember your periodic table, we've got group 1 and 2, the middle block, the transition metals, and then going across here towards the noble gases and the halogens and the non-metals, where we've got a staircase going on like this. So let's have a look at the question. We've got to tick one of these. Yeah, is it in group 1? No. Is it in group 0, the noble gases? No. Sorry. So therefore, the only answer that remains is in the central block. What is a property of copper? It breaks easily, it conducts electricity, does not conduct heat. Well, it doesn't break easily because it is malleable, so that is wrong. Conducts electricity, yes. Does not conduct heat. It's a good conductor of electricity and heat, so it must be that one. A nice, easy 2 marks, I hope. Question 2b. Copper ores are quarried by digging large holes in the ground as shown in figure 3. There's a large hole in the ground. Give 2 reasons why quarrying is bad for the environment. Well, you can have any 2 of the following. You could have visual pollution. You could have noise pollution. You could have dust pollution. And the one that I don't really understand is habitat pollution. That's what it's saying, but hey ho. I think what they're trying to say there is damage to local habitat. That would be my preference to that. Any 2 of these would give you 2 marks. Question 2c. Some copper ores contain only 2% of copper. Most of the ore is rock that is not needed. In one ore, the main compound is copper carbonate. Figure 4 shows the stages used for the extraction of copper from its ore. So we crush the ore, we take the powdered ore, and we separate the rock from the copper carbonate. Okay, and once we've got the copper carbonate, what we do is we add carbon. Carbon reacts with it to form carbon dioxide, and we end up with copper. Why is stage 2 important? Okay, well, stage 2 helps us to remove the rock. So what that is doing is it is concentrating the ore. It allows us to concentrate the ore. Okay, or you could say occasionally you could say the opposite. Remove rock. Either would get you a mark. Question 2c part 2. The equation for the reaction in stage 3 is as below. So we've got 2 copper carbonate plus carbon equals 2 atoms of carbon and 3 carbon dioxide molecules. Okay, from the symbol equation, a company calculates that 247 tons of copper carbonate, okay, are needed to produce 127 tons of copper and 132 tons of carbon dioxide are released. Calculate the mass of carbon needed to make 127 tons of copper. So, let's have a look here. Alright, remembering the conservation of mass. Matter is neither created nor destroyed, it just changes from one form to another. So what goes in must come out. So if we know that there's 247 there, if we add these 2 together, which I'm going to do here now, 127, 132, okay, we're going to get 95259. This is the total at this side, yes? Total here is 259. So the total this side must be 259. So what we need to do, that was our first calculation to get this bit here, okay? To get A, what we need to do here is we need to take 247, or 259 is our total, minus 247. The 247 is involved with the copper carbonate. And if we do that, what we should find is, if we get 2 there, 1 there, the rest goes, we get 12. 12, using our units, remember that, 12 tons of carbon. Okay, that is questions come up a few times. That whole idea that matter cannot be created or destroyed. This side of the equation must balance this side. What goes in must come out. Make sure that you can figure that one out. Question 2C, part 3. Suggest one reason why it's important for the company to calculate the mass of the reactants. Okay, well, there's a number of reasons why we need to know the mass of the reactants. We want to do it from a cost-saving point of view as well, so we don't waste reactants or reactants not wasted or unreacted. I can't fit that in there, so unreacted. So they know how much product they can make. And try and get used to using the words reactant, product. Yeah, so this side is the products, this is the reactant. Okay, and they're using the language in there anyway. Which product is made. Okay, and in our current climate where CO2 is so pernicious, it's important that we record amount released. Okay, so that's linking into the carbon footprint. All right, well done. Question 3. So total it up. You just got 8 marks, by the way. Just total it up here now. Okay, crude oil. Crude oil is fossil fuel. To make crude oil more useful, it's separated into fractions. Use the correct word from the box to complete each sentence. Crude oil is a something of different substances. So, what do you think is the right word looking at the box there? Okay. And the correct answer is mixture. Substances in crude oil have different boiling. Crude oil is separated by fractional distillation. Okay, petrol is one of the fractions produced from crude oil. Car engine use a mixture of petrol and air. Shows some of the gases produced. Okay, so we've got the petrol going in, the oxygen going in, carbon dioxide, nitrogen oxides, and water vapour. What type of reaction happens to petrol in the car engine? Guys, you should know this by now. Reacting with oxygen, combustion reaction. Okay, we've got to try and complete this equation. I'm sure we can have a go at this. Octane is petrol. Okay, CH18. Octane, word equation, nice and easy for us, reacts with oxygen. Okay, and we can just have a look back at our equation here. Look, it's not rocket science. We've got to basically realise that petrol is octane. Octane and oxygen. Octane and oxygen. Yeah, got it? So what's coming out the other end? Carbon dioxide, nitrogen oxides and water. Do you know what? I'm going to put CO2, word equation. Come on, Ainsworth. Carbon dioxide. Okay, nitrogen oxides or water. So that's what I'm going to put into that equation there. Okay, so those are the two best ones you could do. You would obviously be able to accept that as well. Okay, cars use sulfur-free petrol as a fuel. Describe why sulfur should be removed from oxygen. Well, from petrol. When sulfur reacts, yeah, with oxygen, it produces sulfur dioxide. That's your step 1 for the 1 mark, yeah? Knowing that sulfur produces sulfur dioxide. For your second mark, you need to know that this then reacts with water in the atmosphere to produce, hopefully you guys remember this, sulfuric acid, or more importantly, acid rain. So 1 mark for sulfur dioxide, 1 mark for acid rain. Okay. Question 3, part C. Some fractions from crude oil contain large hydrocarbon molecules. These molecules can be cracked to produce smaller, more useful molecules. An equation for cracking decane is decanes gets cracked into propane, ethane, and pentene. Why is propane useful? Propane, is it an alloy? Well, alloy straight away, no. Propane, when we talk about molecules that are polymers, okay, we're thinking about polythene or propene, yeah? So both of them are alkenes, yeah? Not an ane saturated. So that, therefore, is not the case. So it must be fuel, and you might well have heard of propane fuel anyway, okay? Draw in the bonds on this one for ethene, all right? Unsaturated, double bond, done, 1 mark. Okay, guys, what is the colour change when bromine reacts with ethene? Okay, bromine reacts with ethene, and bromine is orange, yeah, and it will go from orange to green, orange to red. We haven't been what are you talking about? That's the only one we've been talking about, okay? Or no change, yeah? But in this case, because it is unsaturated, it breaks that double bond, reacts with it dibromoethane, and it takes the colour out of the bromine water. Right, complete the sentence. Pentene is useful because many pentene molecules can join together to form polythene, okay? Or not polythene, sorry, polypentene. Polypentene. You've got to realise here that it's the enes, the unsaturated ones, okay, that are all joined together like this, that then have this ability to snap off and join together with another one, okay, which then has the ability to snap off and join with another one, forming these long chains. Okay. Well done, you just got 12 marks out of that question as well. Question 4. Polymers and fuels can be produced from crude oil and from plants. There are many types of polymer. Each polymer is different. Polychloroethene is a polymer produced from crude oil. Why is polychloroethane used to make water pipes? All right, well, let's think about this. If we're talking about water, what do we want it to be able to do? Well, we'd need to be waterproof for a start. That would seem to be the most common sense one to start with. Yes? Okay. Decomposes when heated. That might not be very useful. What if you need to bend the pipe and you need to warm it? No good. Does not conduct electricity. So what? Okay. So who cares about that? Who cares about that? It's made from crude oil. How does that make it fit for purpose? Okay. The only thing that is possible, therefore, is it's not biodegradable. If we're putting it underground, if there's bacteria there that would start to break it down, it'd be like making a tube out of cardboard, yeah? So those two there are the reasons. Some shopping bags are made from a biopolymer. Biopolymers are produced from plants. So just one advantage of using a biopolymer. Hopefully you're thinking about one of two things here. Bio means that it is going to be renewable or possibly sustainable, because we can keep using the plants to make it. Fossil fuels are going to get used up one day. They're plants, we can grow more of them. The other thing, seeing that bit of bio, you might be thinking biodegradable. Think back to what we saw when we saw the plastic or the plantic, that plastic that the worms got hold of and started breaking down. Okay, on to question 4b. Some plants have seeds that contain vegetable oil. The flow diagram in figure 6 shows how the oil can be extracted. Mash it up, remove the solids, separate the oil and the water, and then you would use a tap funnel to tap off the various amounts. So once all the water's gone through, you turn it off, get another beaker under there, and off you go again. So use the correct word from the box to complete each sentence. Oil is released from the seeds by, okay, crushing, cold press, yeah, crushing, and solids are removed from the oil and water by filtering. Yeah, bing, bing. That one's definitely not in the place, and we're not doing any of that. Okay? Describe how the tap funnel can be used to separate the oil from the water. Well, I've just done that. Okay, so you would open the tap, yeah, and allow water out. Yeah, going back to the diagram there, out comes the water, turn the tap off. Yeah, tap off. Yeah, and you can either leave oil in funnel and tap off later. Okay. 4. Vegetable oils are used in foods and fuels. Why are vegetable oils important foods and fuels? They are emulsifiers. They have high boiling points. They provide lots of energy. We're talking about food and fuels. So food and fuels. So what? Yeah? What's that got to do with anything? Both foods and fuels need a lot of energy. So think about what both of those would require. Okay? Burning fossil fuels made from crude oil increase the overall percentage of carbon dioxide in the atmosphere. Burning biofuels made from vegetable oil do not increase the overall percentage of carbon dioxide in the atmosphere. Why is this? Remember, back to the idea of carbon neutral. Bing, that should be popping in your head now, okay? So, what happens to a plant? A plant absorbs carbon dioxide from the atmosphere. Okay? This same carbon dioxide is, okay. When we burn a fossil fuel, we release that same carbon back into the atmosphere. Therefore, it is, bing, 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 a carbon neutral. Don't just write carbon neutral. You would not get the 2 marks from that. You need to explain that it absorbs the carbon dioxide from the atmosphere, and then when we burn a biofuel, we release the carbon dioxide back into the atmosphere. Do you see why it's important to check your answers? That's just what I did. Okay, well done. Another 10. Question 5. Limestone is used in many different materials. Heating limestone produces calcium oxide and carbon dioxide. Okay, complete the sentences. The main compound in limestone is calcium carbonate. The reaction to produce calcium oxide from limestone is thermal. Gosh, guys, composition. You'd be all getting full marks on this paper, I'd imagine. Calcium hydroxide is produced from calcium when calcium oxide reacts with water. Okay. And finally, calcium hydroxide is used to neutralise acids because you don't need to know anything here. Yeah, you can just do this without even knowing it. It's an alkali because you know acids and alkalis neutralise each other. Bang, you are flying, guys. Okay, on to the next question, 5b. Right, cement is made from limestone and clay. Concrete is made by mixing cement with water, sand and aggregate. Small bits of rock. Okay. A group of students did an investigation on the amount of aggregate needed to make the strongest concrete beam. The students used this method. Use the same mass of cement and the same mass of sand, but change the mass of aggregate. Okay, so we've got some constants going on here, and this is the thing that we're changing. That's our change. If we're changing it, cows moo softly, I don't care. That is our independent variable. Okay. Use the different concrete mixtures to make beams of the same size. Again, same. Add weights as shown until it breaks. So we're using the same weights again, and we're having the same experimental setup. All right. So we can see here, there's a graph. I don't know what this has got to do with anything at the moment, but we're looking at the mass of aggregate, and we're seeing the force breaks, and we're seeing to start with, as there's an increase in the aggregate up to a point, we're seeing that there's the increase in the force. Then for some reason at 400, yeah, we're getting a massive incline and then it starts to decrease. So therefore, if I was mixing aggregate, I would say that that is our best place to be. Okay, over we go. Let's see what the question is about now. Complete the graph by drawing the 2 straight lines of best fit. Okay, Right, time for the ruler. 2 lines, 2 straight lines of best fit. So we want to go through the first. Okay, just looking here. Sorry, I don't know if you guys can see that. What I'm wanting to do is line up my points like this. Okay, if I line up these 3, no. Okay, I want to be going for those 3, because if you look at how that's going, that's pretty much a straight relationship. So that one, just check I've got it all lined up right. Take my time. So I'm going to just go bang. There you go, cop that. Yeah? So nice and straight, and you can see that from the line I've drawn. Okay? And last 4 points. Okay? Seeing here, that's a really straight line there. You can't get any straighter than that. You'd probably want to line 1, line 2. Okay? I wouldn't be over worried about going over there, yeah? Okay, I think that's good as gold. Next question. Describe one way the student could improve the method so the results are more accurate for each graph point. Well, there's only one way I'm aware of that we can do to do this. Okay? And that really is to do it more times. Okay? So we need to repeat experiment. Okay? And use the repeats to, you've done this a few times in your ISAs, yeah? Calculate a mean for each mass of aggregate. Always bring it back to the question. Repeat experiment, calculate a mean is not sufficient detail. So repeat experiment and make sure that you've mentioned at one stage, be specific, that we're talking about the mass of the aggregate. Okay? 1, 1. Yeah? But link it to your context, the question that you are being asked. Right, what force is needed to break a concrete beam containing no aggregate? Right, well, if it's containing no aggregate, okay, oh, God, crikey. I'm looking here at my line again, going back, no aggregate, it's crossing the axes here, okay, and by my reckoning, each one of these squares is 1, 2, 3, 4, 5 is equal to 2. It's 2 off 40. Yes, it's 40 minus 4. 40 minus 4 by my reckoning is 36. Okay, so that's the number that I'm going to go with there. 36, check newtons, it is newtons on the axis. Okay, good. So, right, that's reading off my graph, that's what I got. You'd read off your graph and do that. One of the students concluded that the force needed to break a concrete beam increases as the mass of aggregate increases. The force needed to break the concrete beam increases as the mass of increases. Let's have a look. Okay. Well, it only works up to a point, doesn't it? And then it starts to decrease. So let's just see here. The student's conclusion is not completely correct. Use values from the graph to explain why. So we know they're not completely correct, yeah? But we need to use the values from the graph. And the value that I've said there was the 400 gram value, yeah? Just let's look at that again to make sure you're all over that like a rash, yeah? Yeah, we've got it here. For that value here, up to 400, that would appear to be true. After 400, no. Okay? So the students, well, okay. The student's conclusion is correct up to 400 grams. Yeah. After this mass, the force needed to break the beam decreases as the mass of aggregate increases. And that, I reckon, is good. Alright, 13 marks, bang, well done. 6. This question is about life, the Earth and its atmosphere. There are many theories about how life was formed on Earth. Suggest one reason why there are many theories. Okay, many theories about what's going on. Okay, 6A. Well, one reason why there's many theories, one reason would be not enough evidence. Okay, and there's no one witnessed it, so you know, we're talking about something that happened billions of years ago, before human observation. Okay, one mark there, possibly one mark there. Alright, let's crack on. In this question, the old good English, right? The Earth and its atmosphere is today not like the early Earth and its atmosphere. Most of the surface was covered by volcanoes, most of it was CO2, water vapour, nitrogen, oxygen now, mostly covered by oceans. Describe and explain how the surface of the early Earth and its atmosphere has changed to form the surface of the Earth and the atmosphere today. Describe and explain how. Okay, well, the oxygens come from plants. Okay, that's one reason. Okay, some of the CO2 has gone into the oceans. CO2 in, yeah. Okay, what else have we got here? Okay, volcanoes. What were volcanoes doing? Volcanoes were spurting out some yuck, yeah. So we've got less volcanoes. So I think we might be in a position to have a go at this, I think. Okay. So the main changes are oxygen increased due to the development of plants. Yeah. CO2 decreased because oceans formed and absorbed it. Also, CO2 became locked up in sedimentary rock and fossil fuels. Good? Alright. And we've got water vapour here, yeah? So let's have a crack at that. What's going to happen to the water vapour here to get to here? It's going to cool. Water vapour cooled to form ocean. Okay. What else could we say there? Well, we didn't have any. Okay, we've got continents here, which is a difference. Okay, and so maybe we can make something about the continents. Continents formed due to plate tectonics. Okay. And as the Earth cooled, it was too hot for them to start with, so they cooled. Okay, and then there's less volcanoes due to crust cooling. So we've got this idea of a hot planet cooling down, water vapour cooling to form oceans. When the oceans formed, the CO2's gone into the oceans. We've also got it getting locked up in rocks as the rocks have cooled down as well. And then we've got the nitrogen and the oxygen happening there. Most of the atmosphere is nitrogen. Didn't touch on that one, did we? We might leave that one for now. Guys, I think you've had a good crack at that one. So, well done, and that, I think, is the end of that paper. Good effort.